Okay, this lecture is over Module 13 of the curriculum, which is on wireless LAN configuration. So why should you take this module? We learned about wireless LANs in the last module, so we need to learn how to configure them. What exactly will you learn? We'll talk about remote site configuration. We'll talk about configuring a wireless LAN using a wireless LAN controller. We'll learn how to use WPA2 Enterprise WLAN on a wireless LAN controller. WPA2 because that's very widespread, very secure protocol compared to WPA or WEP. And then we'll talk about how to troubleshoot problems that you might have on a wireless LAN. So this section starts out with a video. The video is 9 minutes and 12 seconds long. So I will have you watch that outside of this lecture as opposed to playing it here. And we'll move on to the next topic, which is the wireless router. So there are several graphics here. First of all, we have a wireless router. We have the antennas for the wireless, have a power adapter, and then we have ports. So there is a switch built into this, like we talked about. These are often called a multifunction device. And what happens is, whether it be a business or your home, you have an internet connection. You're always going to have a modem. The modem often will connect to your wireless router, and then either directly connected as shown here or wirelessly you will connect to your wireless router. As far as logging into your wireless router, most current, if not all current wireless routers allow you to log in using the HTTP protocol. So here we have a web browser. We'll talk about some common addresses, but 192.168.0.1 is a very common IP address for a wireless router or multifunction device to use. And then when you connect to it, hopefully you have a password on there, and it will ask you for a user ID and password. As far as common IP addresses, there are very many of these. 192.168.0.1 as shown here. 192.168.1.1 is common. 10.0.0.1 is common. 192.168.0.254 is common. That's the last valid address. And there are many others. And these days, used to, you could go on and do a web search and it would say, oh, the default password is admin for the user ID admin if you have a Linksys router, for example. These days, for security, they're forced to not use the same password. So usually this IP address, the username, and password for the administrator account is actually printed on a sticker on the wireless routers these days. As far as basic setup, they have 6 steps here. So the first one we've already talked about, which is to log in to the router. So you went to 0.1 and then you authenticated, and then it will give you whatever the default page is. In this case, it's the setup page. So it's set to use DHCP. The router address 192.168.0.1 was probably already there. You can change that if you would like to use some other. If you're using DHCP, you can turn it on. And basically what this is saying is we will start giving out IPs at 192.168.0.100 and we will go up to .149 or 50 IP addresses. So that allows us to give a range that we would use for DHCP. You should change the default administrative password. You can do that by clicking on the administration in this case, and then here you have the router password, and you can turn that on. The only other thing I see right now is this remote management is disabled. With remote management or remote access, you can connect from outside your home if you know the public IP address of your router and configure it remotely. By default, that's turned off, which would force you to have to be in your house to do that. Okay. The next thing is to log out if it doesn't log you out when you change the password, and then make sure you can log back in using your new password. We talked about the IP version 4 addresses before. So it was 192.168.0.1. So here you're changing it to 10.10.10.0. You should go in, and if that's the subnet you're using, change the DHCP settings as well. Any clients that you have, you would want to go in and release and renew to make sure you get an IP address in the correct range. And then finally, you would want to log into the router using that new IP address to make sure you can do that. So those are some of the steps for going through and doing the basic network setup. So now, as far as the wireless setup, first thing we might want to do is log into the router and go to the wireless tab, and you see that 2.4 gigahertz and 5 gigahertz are both enabled. The SSID or the network name is set to default. You can change that to whatever you would like. The next thing you should do is change the network mode, which is oftentimes auto. Looks like they're changing it to legacy. But if you set it to auto, it will try to negotiate the best connection possible. Here they changed 2.4's name and the 5 gigahertz name to OfficeNet. So that's the new SSID of the access point. We talked about channels last module, so in this case, we're going to go in and force it to be to use channel 6. Then we want to set the encryption mode. So in this case, AES is going to be more secure than TKIP. So we chose AES with WPA personal for the security mode. And then we need to give a passphrase. Obviously, Cisco 123 is not the most secure password, but you'd want to give it a secure password so people can't easily guess it. We talked about this a little bit in the last module, but as far as a mesh network, that is when your home or office is too big to be covered by one access point. So you can have multiple access points. Notice here they set this one to channel 11 and this one to channel 1 in case they overlap. So now we can cover a bigger area. And if you need more than 2, if you need 3 or 4 or 5, whatever, you can go through and create a mesh network. Now, as far as NAT, you should have discussed this in 161. This is network address translation. So this is basically what allows private IP addresses in your home to communicate outside the home. Basically what NAT does is it records the IP address and the port number of the machine originating a conversation or session inside the house, and then it's going to take the source IP address and change it from the private IP address of that machine to the public IP address of your router and send that packet on its way. When the packet comes back, it can look at the source and destination and destination port and look in a table, a NAT address table, and figure out what machine that packet should be sent to that was part of the conversation. Here they're on the status page. They're just showing you the public IP address, the default gateway that it has, and then it allows you to release and renew that for your machine. A lot of routers these days, even multifunction devices for home, have quality of service. So here, under advanced quality of service setup, you can go through and have basically different categories. You can give it the policy a name. You can tell, is this low, medium, or high priority, and then you can give a description over here. So Nutella file transfers are low, and then things like phones and Netflix are high because they're not as tolerant of lost packets, or you cannot recover from lost packets from those types of communications. So we do have a way to do the quality of service. Port forwarding is a very handy thing. What they're showing you here, basically what port forwarding is you connect to a port on the quote outside IP address and port number, and you can direct it to a particular machine, either same port or different port inside your home. So basically what this is saying is if you get a connection outside your home to port 80, what you want to do is you want to forward it to port 80 on the machine 10, 10, 10, 50. I have one for Secure Shell. I say if somebody connects on port 22 outside my home, hopefully it's me, to forward it to port 22 on my Mac OS X server. And then I'm able to log in, and then from there I can work with my router or other devices in my home. So that's port forwarding. 13.1.10 is a packet tracer activity on configuring a wireless network. I am going to assign this, so watch for it to appear in Blackboard. If we look right below here, 13.1.11 is a lab by the same name. So if we were in the classroom using physical equipment, we would probably do this lab instead of the packet tracer. But I will not be assigning this. We will just be doing the packet tracer. And then we will move on to configuring a basic wireless LAN that uses a wireless LAN controller. This video to start out this section is 7 minutes and 14 seconds long. You can watch that outside of class or outside this lecture. This is showing us a typical wireless LAN controller topology. Basically what we have here is we have a router that's connected to a switch. We have a couple of PCs. They're labeled PCs, but this is probably really a server. because it's radius and SNMP, Simple Network Management Protocol. Here we have an administrator PC. We have a wireless LAN controller connected to the switch. We also have an access point connected to the switch. Notice that it mentions it's PoE, Power over Ethernet. So this access point is probably pulling its power from the switch, so you wouldn't need to have an outlet to plug it into. And then we have at least one wireless client connected to this access point. So down here we have an addressing table, tells what interface we're connected to and what is the IP address, or in the case of switch 1 and PCB and the wireless laptop, they're all getting their address using DHCP. Now then, to log into the wireless LAN controller, just like we saw with our wireless router, you're probably going to do this through a web browser. And in this case, it is at 192.168.200.254. And then you're going to have to give an administrator user ID and password and sign in. Once you sign in, this wireless LAN controller is going to take you to the summary page, which is going to tell us that we have what it considers rogue access points with 5 clients, and we have one access point that this is controlling. So that gives you information about the wireless access points. If we go in and click on the access points, it's going to give us more information about the access point. In this case, there is one. It's going to give us MAC address, IP address, domain names. It's going to tell what capabilities as far as frequency and channels that we have. It's going to tell us that we have one client using the 2.4 gigahertz frequency range. We currently have none using the 5 gigahertz. And then it's going to tell you what channels it is using, and then what the channel utilization is. So, there's only one client, not a lot going on at this point. Here we can go through and ping to make sure that we can see whatever 200.1 is. So we're actually on the access point. So we're probably pinging one of the client machines here. It looks like we're pinging the wireless LAN controller. We can say show interface wired 0, and it will give us MAC addresses and IP addresses, broadcast address, how many packets we sent and received, and if we've had any errors. So that's a good way to get some general information about how the access point is functioning. Now, as far as advanced settings, it's going to tell us management addresses. Again, it's going to tell us access points, the version of the software, an emergency image version. So if the current operating system is not working, that's a fallback operating system. They've mentioned rogue access points. You would think it would be bad to see whatever they had, like 51. But rogue access points may be due to neighboring businesses, homes, or apartments where it actually sees the access point, but it is not being managed by the wireless LAN controller. So that might be why that number might appear to be a little high to you. Now, as far as configuring a wireless LAN, what we need to do is we first need to configure the wireless LAN. So in this case, it's giving it a profile name and giving it an SSID, and then setting the ID so you can have multiple wireless LANs. So in this case, it was one. We would then go in and look at wireless LAN, and under General, we would want to make sure that this was set to enabled. Then we want to select what interface this is happening over. So we have an interface called user underscore wireless LAN. Notice that it is broadcasting its SSID. Then we want to secure the wireless LAN. So what we can do is we can turn on preset key. We can set it to ASCII and then type in an ASCII password for the access point. We then want to verify that it is functional. So if we go look at the wireless LANs, we'll see that here's wireless LAN 1. Its name is wireless LAN. That's the SSID. It is enabled, and these are the security protocols or security policies that are being used. Over time, you would want to monitor the wireless LANs to see how many clients there were. For example, if there were any rogue access points, would be a couple of things that you would look for. And then sometimes you want to actually look at the clients. So in this case, we have a MAC address of something that's connected. We have the IP address that it was given. We have the access point that it's connected to and which wireless LAN profile is being used. A lot of times if you look at this in your home, sometimes there will be IP addresses that you'll say, I have no clue what that is. I don't know why I have this device in my network. And a couple things you can do. Usually the first thing I would do is go get the first half of this MAC address, the 0013CE, which is the OUI, the Organizationally Unique Identifier. I would then do a search for that, and it'll come up and tell you who manufactured that. And then hopefully from that you can say, oh yeah, that's my brand new TV I bought, or that's my DVR, or that's my wireless on my cell phone. So sometimes things will pop up. Some refrigerators, maybe you bought a new refrigerator and you didn't realize it had a wireless connection. So sometimes it's interesting to monitor the clients and look at that information. 1327 is a packet tracer activity. Configure a basic wireless LAN using a wireless LAN controller. I plan to assign this, so watch for that to appear in Blackboard. And we will move on to the next section, which is configure a WPA2 enterprise wireless LAN. It starts out with a video that's going to talk about Radius, which is an authentication system we've talked about several times. Simple network management protocol server, SNMP, we just mentioned that a little bit ago. This video is 5 minutes and 36 seconds. I will let you watch that outside of class or outside this lecture. So SMTP is a way to send out management information. If you're talking about on servers, it may say, warning, my root partition on this Unix server is at 95%, and possibly turn something red to tell you that something that's not necessarily super desirable may be going on, so that hopefully you can get on and free up disk space before the disk gets full. It may say, hey, I'm a wireless access point, and for some reason I have 200 clients connected to me, which is above my threshold that somebody told me was normal. So those are some things you can report with SNMP. Here we have the same topology we had before. So here it's labeled as a PC, but again, it's probably a server class machine. That when you go to log into the access points, it's going to hand off the authentication to the Radius server. And if we're doing any of our accounting or error recording, we would send that to the SNMP server, which is also running on this computer. I don't know if they've mentioned it, but Radius stands for Remote Authentication Dial-In Service. So that's what that stands for. Here we're talking about configuring an SMP server. Unfortunately, this one doesn't. Oh yeah, I guess it does have the zoom in cursor. Not sure why I didn't catch that the first time. So under management, under SMP, we have something called trap receivers. This is going to be the different categories or different policies, if you will, for these to receive. Here we have an IP address of the SNMP server. It's enabled, and we have something called a community name, which is really like a password. In this case, it was set to CCNA version 7. To configure the Radius server, what we're going to do is we're going to go to Security, go to Radius, go to Authentication, and create a new rule for authenticating users. So here we would give it a number or a priority. So this is high priority. This is the IP address. Here's the shared secret to encrypt messages to and from this server, and then you have some timeouts that you can set. Once you've configured these the way you want, then you can click apply. And then when we go in and verify this, it'll say here's server index 1, here's the IP address, the port, IPsec, which is IP security. Layer 3 security is disabled. The admin status is this rule is enabled. So 11.3.5 is a video on configuring a VLAN for a new wireless LAN. This video is 5 minutes and 5 seconds, but I'll let you watch it outside of class as well. Okay, this next section says topology with VLAN 5 addressing. So this is the same topology we had before. Think we had the wireless LAN controller. Over here we have the Radius server, but what we're going to do is we're going to configure a VLAN on this router interface to have our wireless devices. So if we log into router 1 and say show IP interface brief, notice down here that we have sub interfaces, so .1 and .5, and then we have IP addresses associated with that. So if we were going to create a new interface, the first thing we need to do is go to controller and choose interfaces, and then click the new button to say that we want a new interface. Then what we need to do is go in and configure the VLAN. So once we say we want a new interface, the interface is called VLAN 5, and it actually carries VLAN 5, so the name is very descriptive as to what it is. Then what we need to do is we need to go in and pick information about VLAN 5. We need to give IP address, net mask, and default gateway for that interface. Then the next thing we need to do is configure the DHCP server. So again, we give it a DHCP server. We only have one, so we give the address of that DHCP server. We want to apply and confirm, and then verify that our interface is there. There's VLAN 5, there's the IP address. It's a dynamic interface. So basically confirm that everything we configured is the same. 13.3.5 is, or 13.3.8, sorry, is a video called Configure a DHCP Scope. I'm going to play it. It's 3 minutes and 35 seconds long.
Hello everyone, I hope you're ready. We are here to deploy a DHCP scope on the wireless LAN controller. DHCP? I thought that was on the router. Well, we're going to deploy a DHCP scope, which is very similar to a DHCP pool, but we're going to do this on the wireless LAN controller. And we're going to do this because we want to provide management IP addressing to management devices using DHCP, all controlled from the WLC. Now, this is a specific use here. We're going to provide IP addressing to management devices. We're talking access points that are joining our wireless LAN controller, and we're talking possibly a management PC that would be used to configure the wireless LAN controller. So let's get started. Just a quick reminder here as we get started in configuring the wireless LAN controller, but we are going to be configuring a DHCP scope, not for providing hundreds of users IP addressing. We're creating a DHCP scope to provide dynamic addressing to management devices on the management network, which includes a management machine, as well as our lightweight access points that'll be joining with our controller. So let's get started. We're going to go into the advanced section first. When I click on advanced, we'll have our new screen come up. And inside of this area, we're going to go into controller. Within controller, on the left side, we're going to look for the internal DHCP server. And again, this is very similar to a DHCP pool on a router. DHCP scope looks just like a DHCP pool. I'll click on DHCP scope, and we'll see we're going to have an address pool, lease time, and some other info. Let's get started by clicking New, and you'll give ourselves a scope name, such as management_IPs. That's a beautiful name for management purposes. With the name of management IPs, I can click on that name I've created. It'll load a new screen for me to fill out all the information regarding my DHCP scope. We're going to begin with the pool start address, and this is going to be the first IP address that I'm going to have my DHCP service provide on this management subnet. And that'll be 192.168.200.220. This is the first IP address I'd like to provide on this management network by using this DHCP scope. And the last IP address would be the pool end address. I'll make that 192.168.200.240. In all, I'll be providing up to 20 IP addresses using this management scope. It allows me to deploy up to 20 lightweight access points, or a dozen, and then some other IPs for management purposes. The network itself is 192.168.200.0, and the subnet mask for this management network is all 255s ending with a .0. The lease time we leave at the default. The default router is the exit point for the network. That is not us on 200.254. We're a controller. The exit point is going to be the router's IP address, which is router R1, which is 192.168.200.1. Our scope is good. We need to just enable this. So we'll change the status from disabled to enabled, and we can go ahead and click apply. Our scope is now created on the wireless LAN controller, and now we can verify it's ready to be allocated to a new wireless local area network.
Okay, 13.3.9 is entitled Configure a DHCP Scope. Basically what a DHCP scope is it's an administrative grouping of IP addresses associated with a subnet. So the first thing we're showing here is creating a new DHCP scope. So this would be under controller, internal DHCP server, create a new one. And when you did that, it would bring up this screen that would ask you to name it. So in this case, this is going to be IP address for management machines or management ports. Here they're just saying go in and double check and make sure that the scope was created. And basically the address pool has not yet been defined. So what we want to do is we then want to go in and say we want to start at 200.240, go to 200.249. It's on network 192.168.200.0. We're using a Class C subnet mask 255.255.255.0. Our default gateway is going to be 200.1, and we're going to make sure that this is enabled. And then we want to verify the scope. So notice now there is an address pool. So we want to make sure that that's the right address range. And then we should be set to go. 13310 is a video titled Configure a WPA2 Enterprise Wireless LAN. We're going to talk through this. This video is 5 minutes and 24 seconds, so you can watch that outside of class. But basically what it's going to talk you through is creating an enterprise wireless LAN using WPA2 encryption. So basically the first thing we would do, like before, is we would create a new wireless LAN. In this case it's called Wireless Lab. We would turn on WPA2 authentication. We would then go in and configure the SSID. In this case we give a profile name that matches. We would then go in and enable the wireless LAN on VLAN 2. So basically we would enable it, we would choose the interface, and then we would apply it, and then it will ask us if it's okay to apply this, that the wireless LAN will be momentarily disabled and there will be a radio reset, and some of your clients may lose connectivity. So if you really think it's safe to do that, or this is the best time to do it, you would click OK. You would then go in and verify that AES encryption is turned on and that we're using 802.1x, and then apply that. If we were going to use a radius server to authenticate, we would go through and turn on AAA authentication or authentication authorization accounting server. We would give its IP address and tell what port that was on, and once we were happy with the settings, we would click apply. And then we would go through and verify that the wireless LAN, in this case with ID 5, was up and running, and notice that it is using WPA2 and 802.1x authorization, which is what we want. 13312 is a packet tracer activity that lets you go through and do what we did in the previous section, the configuration of an enterprise WLAN. I will be assigning this, so watch for it to appear in Blackboard. And we'll move on to 13.4, which is on troubleshooting. These are kind of a typical approach. A lot of times this is shown with a flow chart. You need to identify exactly what the problem is, either with the user or yourself. You need to figure it out. You need to think about what the probable causes are, and out of those causes, which one is the most probable. You need to test that theory by trying to determine the cause and fix the cause. You do that by establishing a plan. Once you do that, you verify that the system is functional again. If it is not functional, then you go back to your theories that you created, or create new theories as to what the cause may be, and kind of go through a loop there until you fix the problem. And then once you fix the problem, you should document that, just so this time you know what the problem was, and if you have this problem in the future, you possibly know how to fix it. Or if you have a new network engineer, maybe this isn't a knowledge base and they're having a similar problem, and your notes and documentation will help them fix the current problem. So what they're showing here is a very common thing. We have an access point and we are unable to connect to it for some reason. And the first thing I would say is a lot of laptops have switches that actually turn the wireless off. So the first thing is always, is it actually turned on? So you might look for those switches. Toshiba laptops are notorious for having these switches and having them poorly located on the sides. So if you're handling your PC, oftentimes you inadvertently turn off the wireless. I've even talked to somebody before to say, show me what you do when you're done with your computer. And they take the wireless switch and go, well, the first thing I do is I turn it off. And they're actually turning the wireless off. And then they close it. And when they open it, they turn it back on by sliding that switch. And in this particular case, they had forgot to, quote, turn it on, slide the switch up so the wireless was on. So first thing is make sure it's on. The second thing is to go in and use ipconfig and make sure that it's got an IP address via DHCP or is configured with a static address, and make sure that IP address and net mask that it gives you makes sense. If you can connect to a wired network and make sure that works, then you know that the TCP/IP protocol stack is working. You might check the drivers to see if there are new drivers for your wireless NIC. And then you might look at the security mode that your PC is using and make sure that matches the security mode of the access point. If the connection is working, but it's not working well, how far is the device from the access point, and how many obstructions or walls might you be passing through? So if you have your access point at one end of the house and you're with your laptop in the bedroom and it's going through 6 walls, that will really degrade the signal and possibly degrade the performance of the network. Make sure the channel settings are appropriate. Make sure you're connected to the correct SSID. And then, are there other devices, for example, a cordless phone, baby monitors, microwave ovens, etc., that might be interfering and causing a degraded signal or possible disconnects? And then, depending upon what problem you have, will dictate how you might fix this. If your network is general, if your wireless clients have updates as far as better protocols that they might be able to use, you can do that. The other way is to split your traffic. A lot of modern day multifunction devices actually have a 2.4 gigahertz channel and a 5 gigahertz channel. And what you can do is you can split the traffic between them. For the 2.4, you might want to try to put clients that are doing email and web surfing and that type of thing, and then put your devices such as your TV or things that need higher performance on your 5 gigahertz band. So that's one way or a couple ways to improve performance. The other is routers have firmware, so you can go through and see if the firmware is up to date. Here it's telling us it is, so we're okay, but if there's a firmware update, you might click a button to update it, or you might have to download it. There are different ways that you update the firmware on multifunction devices, but you might want to check that. The other thing they aren't really talking about, but up here they're talking about channel utilization. This is not really that bad, but if this was like 95% and this is 14, then you might want to try to move some of your devices down from channel 6 to channel 44. So that's something that you could look at. 1345 is a packet tracer related to troubleshooting wireless LAN issues. I will be assigning that. So watch for that to appear in Blackboard, and we will move on to the module practice and summary. I think normally it says practice module and quiz. So with new curriculum, possible slight inconsistency. The practice starts with a packet tracer on wireless LAN configuration. I will be assigning that, so watch for that to appear in Blackboard. The next thing we have is what did I learn in this module. So read through that on your own and make sure you are aware of all these different things that are discussed. And then finally we end up with the module quiz, which you can do on your own. That's over all of module 13. And with that we finish up the module 13 of the curriculum.